Hello again. Today is Tuesday. Wait a minute. Today is Tuesday, February 7th, 2022. It's amazing that we are almost one quarter of this month already. So soon it will be the end of February, and that means we passed 2 months of the new year. This year is a rabbit year, so I think the time does not fly but jumps quite quickly or runs away quite quickly, just like a rabbit. So let's not to waste our time, but use our time to the fullest. As before, like 10 minutes ago, I would like to read another article regarding dynamic DNS, and this one is from Wikipedia. Wikipedia frequently offers quite an extensive insight into things that are around us. Sometimes they are too much extensive, but sometimes they are very good. And I think this article, judging by the size or length of the article, is also good. But by current standards, it's quite a long article. But since it's an American English article, I think it's quite an informational, and it will explain every ins and outs of DDNS, just like the way the Americans explain things. They are quite lengthy in their explanations usually. So I'm gonna focus on how to pronounce words, and also I will just try to remember or memorize keywords, new expressions, cliches, idioms, and good sentences that I judge would come in handy when I work in the US or when I communicate with foreigners over the phone, via email, or face-to-face conversations. So here we go. Dynamic DNS. This article needs additional citations for verification. November 2022. So as you know, Wikipedia is just needs constant update and constant modifications, corrections, because one guy starts to offer his or her ideas, explanations about a certain idea, and that explanations could be wrong or need some explanations themselves. So everybody chips in and tries to correct further. So this one says it needs additional citations, okay? Additional citations for verification. Dynamic DNS, DDNS, is a method of automatically updating a name server in the domain name system when often in real time with the active DDNS configuration of its configured host names, addresses, or other information. The term is used to describe two different concepts. The first is dynamic DNS updating, which refers to systems that are used to update traditional DNS records without manual editing. These mechanisms use TSIG to provide security. The second kind of dynamic DNS permits lightweight and immediate updates, often using an update client, which do not use the RFC 2136 standard for updating DNS records. These clients provide a persistent addressing method for devices that change their location, configuration, or IP address frequently. Background. In the initial stages of the Internet, ARPANET, addressing of hosts on the network was achieved by static translation tables that mapped host names to IP addresses. The tables were maintained manually in form of the host file. The domain name system brought a method of distributing the same address information automatically online through recursive queries to remote databases configured for each network or domain. Even these DNS facilities still needed static lookup tables at each participating node. IP addresses, once assigned to a particular host, rarely changed, and the mechanism was initially sufficient. However, the rapid growth of the Internet and the proliferation of personal computers in the workplace and in homes created the substantial burden for administrators of keeping track of assigned IP addresses and managing their address space. The Dynamic Host Configuration Protocol DHCP allowed enterprises and Internet Service Providers (ISPs) to assign addresses to computers automatically as they powered up. In addition, this helped conserve the address space available, since not all devices might be actively used at all times, and addresses could be assigned as needed. This feature required that DNS servers be kept current automatically as well. The first implementations of dynamic DNS fulfilled this purpose. Host computers gained the feature to notify their respective DNS server of the address they had received from a DHCP server or through self-configuration. This protocol-based DNS update method was documented and standardized in IETF publication in 1997 and has become a standard part of the DNS protocol. See also NS Update program. The explosive growth and proliferation of the Internet into homes brought a growing shortage of available IP addresses. DHCP became an important tool for ISPs as well to manage their address spaces for connecting home and small business end users with a single IP address each by implementing network address translation at the customer premises router. The private network behind these routers uses address space set aside for these purposes, masqueraded by the NAT device. That's good word, masqueraded. Masqueraded. Yeah, I'm pissed off somewhat. I don't know why, but I'm going to relocate to my room, and I'll just lie down with my belly lying on the floor of bed, and I will continue to read this article. If you live in Korea, you know what I'm talking about. But if you have a bed in America, also you know what I am up to. I'm just lying down with my belly. So, where were we? Yeah, NAT is quite an important term. The private network behind these routers uses address space set aside for these purposes, masqueraded by the NAT device. Masqueraded. This, however, broke the end-to-end principle of Internet architecture and methods were required to allow private networks with frequently changing external IP addresses to discover their public address and insert it into the DNS, into the domain name system, in order to participate in internet communications properly. Today, numerous providers called dynamic DNS service providers offer such technology and services on the internet. Domain name system. DNS is based on a distributed database that takes some time to update globally. When DNS was first introduced, the database was small and could be easily maintained by hand. Masqueraded. As the system grew, this task became difficult for any one site to handle, and a new management structure was introduced to spread out their updates among many domain name registrars. Registrars today offer end-user updating to their account information, typically using a web-based form, and the registrar then pushes out update information to other DNS servers. Really? That's good. So registrars today offer end-user updating to their account information, typically using a web-based form, and the registrar then pushes out update information to other DNS servers. Pushes out. Web-based form, updating, end-user updating. Okay. Got it? Due to the distributed nature of the domain name systems and its registrars, updates to the global DNS may take hours to distribute. Thus, DNS is only suitable for services that do not change their IP address very often, as is the case for most large services like Wikipedia. Smaller services, however, are generally much more likely to move from host to host over shorter periods of time. Servers being run on certain types of internet service provider, cable modems in particular, are likely to change their IP address over very short periods of time, on the order of days or hours. That's a good term. On the order of days or hours. Like, 10 to the power of 2, 10 to the power of 3. There's order, one order higher, okay? On the order of days or hours. Dynamic DNS is a system that addresses the problem of rapid updates. DNS is a system that addresses the problem of rapid updates. Let me stop here and get replenished. So types. The term DDNS is used in two ways, which, while technically similar, have very different purposes and user populations. The first is standards-based DDNS, which uses an extension of the DNS protocol to ask for an update. This is often used for company laptops to register their address. The second is proprietary DDNS, usually a web-based protocol, normally a single HTTP fetch with username and password, which then updates some DNS records by some unspecified method. This is commonly used for a domestic computer to register itself by a publicly known name in order to be found by a wider group, for example, as a game server or webcam. End users of Internet access receive an allocation of IP addresses, often only a single address by their Internet Service Provider or ISP. The assigned addresses may either be fixed, that is static, or may change from time to time, a situation called dynamic. Dynamic addresses are generally given only to residential customers and small businesses, as most enterprises specifically require static addresses. Dynamic IP addresses present a problem if the customer wants to provide a service to other users on the internet, such as a web service. As the IP address may change frequently, corresponding domain names must be quickly remapped in the DNS to maintain accessibility using a well-known URL. Many providers offer a commercial or free dynamic DNS service for this scenario, for this story, for this situation, for this scenario. The automatic reconfiguration is generally implemented in the user's router or computer, which runs software to update the DNS service. The communication between the user's equipment and the provider is not standardized, although a few standard web-based methods of updating have emerged over time. Standards-based DDNS. The standardized method of dynamically updating domain name server records is prescribed by RFC 2136, commonly known as dynamic DNS update. The method described by RFC 2136 is a network protocol for use with managed DNS servers, and it includes a security mechanism. RFC 2136 supports all DNS record types, but often it is used only as an extension of the DHCP system, and in which the authorized DHCP servers register the client records in the DNS. This form of support for RFC 2136 is provided by a plethora of client and server software, including those that are components of most current operating systems. A plethora of client and server software. Support for RFC 2136 is also an integral part of many discovery services, including LDAP and Windows Active Directory domains, LDAP and Windows Active Directory domains. Applications. In micro Windows networks, dynamic DNS is an integral part of Active Directory because domain controllers register their network service types in DNS so that other computers in the domain or forest can access them. Network service types. Increasing efforts to secure Internet communications today involve encryption of all dynamic updates via the public Internet, as these public dynamic DNS services have been abused increasingly to design security breaches. Standards-based methods within the DNS SEC protocol suite, such as TSIG, have been developed to secure DNS updates, but are not widely in use. Microsoft developed alternative technology, GSS, TSIG, based on Kerberos authentication. Some free DNS server software systems, such as DNS Mask, support a dynamic update procedure that directly involves a built-in DHCP server. This server automatically updates or adds the DNS records as it assigns addresses, relieving the administrator of the task of specifically configuring dynamic updates. DDNS for Internet Access Devices. Dynamic DNS providers often offer a software client program that automates the discovery and registration of the client system's public IP addresses. The client program is executed on a computer or device in the private network. It connects to the DDNS provider's systems with a unique login name. The provider uses the name to link the discovered public IP address of the home network with a host name in the domain name system. Depending on the provider, the host name is registered within a domain owned by the provider or within the customer's own domain name. These services can function by a number of mechanisms. Often they use an HTTP service request, since even restrictive environments usually allow HTTP service. Most providers have an API similar to a first provider DNS or DIN dynamic.com, so it is often called DIN DNS too. Many home networking modem routers include client applications in their firmware compatible with a variety of DDNS providers. Applications in their firmware. Okay. DDNS for security appliance manufacturers. Dynamic DNS is an expected feature of often or even requirement for IP-based security appliances like DVRs and IP cameras. Many options are available for today's manufacturer, and these include the use of existing DNS services or the use of custom services hosted by the manufacturers themselves. In almost all cases, a simple HTTP-based update API is used as it allows for easy integration of a DDNS client into device's firmware. Okay, let me read this one more time. In almost all cases, a simple HTTP-based update API is used as it allows for easy integration of a DDNS client into a device's firmware. There are several pre-made tools that can help ease the burden of server and client development, like Mint DNS, CURL, and INADIYN. Most web-based DDNS services use a standard username and password security schema, security plan, security account, security schedule. Okay, schema, that's good word, man. Security schema. This requires that a user first create an account at the DDNS server website and then configure the device to send updates to the DDNS server whenever an IP address change is detected. Some device manufacturers go a step further by only allowing their DDNS service to be used by the devices they manufacture, and also eliminate the need for usernames and passwords altogether. Generally, this is accomplished by encrypting the device's MAC address using a cryptographic algorithm kept secret on both the DDNS server and within the device's firmware. The resulting decryption or decryption failure is used to secure or deny updates. Resources for the development of custom DDNS services are generally limited and involve a full software development cycle to design and field a secure and robust DDNS server. A full software development cycle to design and field a secure and robust DDNS server. Field a secure and robust DDNS server. Okay, it's quite aesthetic. List of managed DNS providers, comparison of DNS server software, multicast DNS, an alternative mechanism for dynamic name resolution for use in internal networks, alternative DNS route, jailbreak. Tor services also uses a domain that doesn't need for a static IP. Okay, so it was a good article, but not technical. I mean, there's no information about how to set up IP time or TP-Link or D-Link wireless routers, but you can figure them out by referring to their manuals. What is important is there are two types of DNS updates. One is inside the network for LDAP and Active Directory services. The other one is like for outside network's own use. I was interested mainly about the outside update. So they say the automatic software program, client program, a plethora of software update in the firmware. Sometimes you don't need ID and password because the device itself can encrypt the MAC address and decrypt it at their server side later so that updates or other stuff can be done easily. And when you request, usually it is based on HTTP request because many routers devices allow for HTTP communication at the minimum. So we learned the address space, a plethora of software, and also standards-based update. Standards, it was a plural. What else? Schema. We learned the schema word, schema. There are not many words, expressions to remember. They were very easy, but it was purely technical terms, DVRs, IP cameras, and so on. So take care and have a good night. Bye-bye.